Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode problem 1014. Best sightseeing pair. This question is based out of array and asked in Google recently. It's a Google interview question. Let's have a look on the problem statement. Here we are given integer array values, where values I represent the value of the ith sightseeing spot. Okay, and two sightseeing spot ij have a distance of j minus a between them. That's fine. And what is this? The score of the pair I and j, where I is always less than j. The sightseeing spot score is value of I, value at j plus distance between them. Value at I plus values at j plus distance between them. What is the distance? J minus I. And I can write it like this. So this is the score of that sightseeing pair. And what we have to return is return the maximum score of any pair. Okay. Let me explain it to you with the help of an example. We are given an integer array and these are the sightseeing spots, and we have to choose a pair from these sightseeing spots. So pair of those spots are, let's say, like I and j I have chosen, and I is first index is I, second index is j. It means these are in order 0, 1, 2, 3, 4. I is less than j. Okay, then score of that pair is value of that particular index, first index, value at the second index plus distance between them. I is always smaller than j, so it's always negative. It will shows that the sum of both the values minus the distance between them. So this is our score, and this is the score of that particular pair of indices I comma j. And what we have to return is return the maximum score of any pair. This much we have to do. This is input and this is our output and this is our operation. So ultimately what we have to do is we have to find any pair I comma j such that this score is maximum. And let's say if I have to check all the pairs, then what do? I can write nested for loops. First for loop will go from I equal to 0 to n minus 1 or n minus 2, and then second for loop will go from I plus 1 to n. Okay, let's say if this is my first index, these many can be my second index. If this is my first index, these three can be my second index. If this is my first index, these two can be my second index. We are having n elements, and for the first item we are having 4 possibility, then 3, 2, 1. So it will be like sum of first n natural numbers, like n into n plus 1 by 2. In short, the time complexity will be around n square. So we are using two loops. First loop for I and second loop for j. And using this loop, I am able to check all the pairs. If I know all the pairs, if I know I and j, I will be able to get value at I, value at j, and this value. And that score I can maximize using a variable. Okay. So if I check all the pairs using two nested loops, then the time complexity will be order of n square. And what about the space complexity? I'm not taking any extra space in this case, just a couple of variables. Okay, so to order of n square is going to give us TLE in this case as per the test cases. So we have to think of some better approach than checking all the pairs. Here this is the input given to us from which we have to find a pair I and j, where I is less than j, and this will be the score of that particular pair, and we have to maximize this score. Okay, and if you try to have a look on this expression, this is dependent on I and j, only these two variables. So if I write it something like this, in this case this first portion is dependent on only I index, and the second portion is only dependent on jth index. Okay, and you already know that the I index is less than j. So let's say if I have chosen the 0th index as my ith index, then what are the possibilities of j? These are the possibilities of j. Okay, and I do one thing. I iterate over the given array using the j pointer. So I can go from 1 to n minus 1. This is my second pointer, or you can say second variable. Let me name this portion as first portion and second portion of my score, and I have to maximize the first plus second. So that's it. Just this j is iterating over the given values for second portion, right? And I will choose that second portion which is maximum. Okay, let's say I have chosen j equal to 3, and what are the possibilities that I can have for I? Those are from 0 to 2. If I chosen second portion for j equal to 3, for the first portion will be from 0 to 2. And from the for the first portion also, I can choose in a greedy fashion. I will choose the maximum one, whatever is giving me the maximum result. So j is going along with my loop, and for the first, I will keep on checking the maximum portion, maximum value for the first I am getting. Let me make a dry run over the given example. Initially, my I pointer will be at 0 and j pointer will be at 1 because we require a pair. Now calculate the score. What is our score? Score in this case is for the first value is 8 and index is 0. So 8 plus 0 is the score for first. And what about second? Value minus j. Value is 1 minus index is j. 8 plus 0. The score is 8. So current maximum score is 8 so far. Now what I will do is I will increment my j pointer, and j pointer will be pointing to 2. Now in this case try to get the score, and I will increment the ith pointer only in the case where I am getting a better value of I. So I is getting better value at 0 index only, so there is no need to increment the pointer I. Now just calculate the score. For first, it will remain same, 8 plus 0. For second, it is 5 minus 2. 5 minus 2 is 3. So 11. 11 is better than 8. So 11 is my current maximum score. And now I will keep on incrementing my j. J will go here and j will go here. At index 3, we will have some value. At index 4, let's try to calculate that as well. And I is not getting incremented because I is giving maximum value at this position. And after this position, all the values are minimum, so I am not incrementing I. And j I am using to iterate over this values array. So when j was 1, it was the case. J was 2, it was the case. J was 3, I am not writing it. J was 4, let's check it. 8 plus 0, 6. 6 is the value, minus 4, which is 2. 8 plus 2, which is 10. 10 is also not better than my current captured answer. Current captured answer is 11. So 11 is going to be my answer. So what I did is I iterated over the values array from j equal to 1 to n minus 1. And I did one iteration. And j will only be incremented if it is getting better value. And how it is getting incremented? While capturing j is visiting all the indices from 1 to n minus 1. And I is currently at 0. And I is currently at 0 and j is going from 1 to n minus 1. So I have possibilities to be compared with every other index. So I is going to have the first maximum portion and j will be having second maximum portion, and the sum of that is my score, and I will capture the maximum score. Okay. So what I will do is, what I have done is I have only done one single iteration over the given input. And if it is a one single iteration, then what is the time complexity? Time complexity is order of n. What about the space complexity? Here also we have taken couple of variables. So space complexity is constant in this case. So from order of n square to order of n, we have improved the time a lot. So this solution is going to be accepted. And now let's try to write the code for this. For my first index, I'm keeping it at 0. And for my second index, I'm iterating over the values. J equal to 1, j less than n, j plus plus. And what is n here? Int n equal to values dot length. Okay. And I don't care about this index. I require the first portion. First portion is values I plus I. And what about the second portion? Second portion is values j minus I as per the expression. Okay, this is my first and second I have captured. And I also require an answer variable which is going to store my answer, and answer is, we have to maximize it, so I'm initializing it with integer dot min value. And after doing my operation, in the end I have to return answer for sure. And now this is second. Now I have first and second with me. I can capture my answer. Answer is math dot maximum current answer plus first plus second. And now it is the time to update first if required, because second is always getting updated. So first is equal to math dot max. I will also keep my first to the maximum portion. So current first plus the values and values at the current index plus the current index. Current index is j, so it will be values at j plus j. Okay, so I had two portions, first and second, and the sum of those is maximized is my answer, and then updating the first. And am I using this I anywhere? The first is initialized with 0 and 0. I don't require this I. Let me test our sample test cases. Sample test cases are passed. I'm submitting the problem. It is submitted successfully. I hope you have understood the approach. Thank you guys. If you have any doubt, you can comment down below. I will try to address. Bye bye.